Hello everyone. In this video, we are going to explore a new Lithophane function in LuBan. Let's open LuBan software. Go to File, Create, Lithophane. As you might have already familiar yourself with LuBan Lithophane, you'll know that most of the functions has a predetermined shape. The exceptions are stencil, balloon, and box. These three functions depends on an input black and white image, and this image is also called stencil or template image. You can customize the shape. Then the last three functions, the shapes bronze, tatum, and the new function tile, depends on an input 3D model. In the bronze function, the color of the grayscale of the Lithophane is determined by the surface gradient of the 3D model, so that the final results gives you a bronze-like object. The tatum Lithophane applies a photo onto the 3D model, but it can only work on the 3D object with a revolving axis. For example, it works with a heart shape. You can apply a photo onto the heart shape, and there is some slight distortion at the top, and very often it is not that important. So let's open a photo to just show an example of this, so that you can understand what is the difference of the tatum with the existing method. Resolution set to 0.5, 0.4, okay. So this is the kind of tatum method. It wraps around the photo to the 3D model, but the 3D model has to have some revolving axis. If a 3D model does not have revolving axis, such as this one, a cat model, then we will get problem. We will get problem in this region. Okay, so we can change the 3D model to the cat, and let's see what the Lithophane looks like. This will be your Lithophane if you use tatum based on the cat. The photo is distorted. The tile Lithophane, the new shape or new function, is added to partly address the problem. In the tile function, the photo will be applied to the 3D model in the form of a tile. You imagine the floor tile, that kind of thing. And it works best with repeated pattern in the photo. If your photo is the one that we just used, baby shark, you will see that there is still some distortion. The distortion won't be as severe as the tatum method, but there is still some distortion. However, if you apply a repeated pattern as the photo, then it will be better. So this is the baby shark image. When you apply this to the tile, based on the tile to the 3D model, you will still get distortion. But it will be better if you use a repeated pattern. And let me show you two patterns that I'm going to use. That's the first pattern we will try, and that's the second one. They are similar. They are similar in the way that they are just repeated pattern, so the artifacts won't be that visible. I'm going to apply one, and this will be the kind of Lithophane you will get. If we turn off the display, turn off the background color, you will get a sense of the up and down, the concave and convex surface variation. And the surface variation encodes the thickness of the lithophane. And when the backlight is on, the different thickness gives you bright and dark stripes. The second pattern that we are going to test is based on the pattern on a leopard. The model was a cat, so let's turn it into a leopard. That's the x-axis. X-axis, the pattern is a bit too dense, so let's try the y-axis. Did I click? I think I clicked Y. So when you change the axis of application of the, if you change the axis, the direction to apply the photo, it takes quite some time to recompute all the 2D to 3D mapping relationship. But after a while, it will come back. As long as LuBan doesn't close itself, you just need to wait. Okay, it is back. It is back with a leopard skin pattern. And same with direction Z. I'm not going to try this because it takes some time to calculate. Then you will have the common control parameters. Model size X, Y, Z. If you change one and hit the enter key, the other two will change accordingly. You will also have minimum maximum thickness resolution, as well as a special control for the pattern itself. It can slightly rotate the pattern. Let's say from 0 to 5 degrees. I hit the tab key. The pattern is slightly rotated. You can only look at it, you can only observe the rotation by looking at it closely. Since it is a repeated pattern, the rotation may not seem that clear in our current example. The next thing I want to do is I want to show you how to change the scale of the pattern. Currently, the pattern looks quite nice. And if we open the pattern, it's actually leopard skin. If you want to make the pattern a bit bigger, you can make the image smaller. I crop the small region from the leopard pattern, and I'll save it as a new JPEG file, P3. Then I will apply the new image. The pattern will be bigger when it's applied. Wait, it didn't change, did it? Let me see. P2 and P3. P5. Oh, sorry, P3. I think I loaded a different pattern. P3, I should pick this one. P5 is the original pattern. It's the original pattern. Okay, so the pattern becomes bigger. P5 is smaller. That is because when we apply the mapping, 2D mapping to 3D, the algorithm will try to use the entire image. So the smaller the image, the bigger the pattern that it will seem to be. And the larger the image, the more dense is the pattern. So that is the way to control the density of the pattern on the 3D model. Last but not the least, if you input a watertight 3D model, your generated lithophane, tile lithophane, will also be watertight. LuBan simply creates an external surface or an internal surface, depending on the options you select, or an internal surface onto the 3D model. So the solid input becomes double surface, a hollow model. To make it a lithophane, as we all know, you have to put a light source in the model. And the best way to do it, in my opinion, is a post-processing process. This is the one we generate. You can click Save Model and save the project onto an export folder. Here, I'm going to directly jump to Mesh Cut. Select OK. I will use planar cut and cut off the base. The planar cut function can cut off the base, and I prefer to generate no connector because I only want the upper part. The bottom part will be discarded. And then save it. So this model has black and white grayscale information, so they will be saved as OBJ files. You can use LuBan to convert OpenOBJ and then export to STL, depending on the requirement of your slicer. But most slicer can work with OBJ files also. It's a dense model, so it takes some time to process. Once it's done, we will take a look at the upper part of the model. And this will be our Lithophane. Okay, it's done. I'll press J to look at the two models, part 1 and part 2. Oh, part 9. Okay, so it has some artifacts, apparently. It has some invisible... Wait. Okay, so part 2 is our actual model. Then the rest are artifacts. Unfortunately, the tile function may generate a model with some defects, but hopefully they won't affect your printing. I'm going to open the planar cut results. We are primarily interested in part 2, and this is our Lithophane. OBJ files takes longer to load than an STL file. Okay, that's it. This is our Lithophane. You can save it, file export as STL if you want. Part 2. Then we will open the STL file, which has no color information. I believe our setting, the last setting was internal Lithophane, so the surface variation was generated on the inside. An external Lithophane would be better. An external Lithophane will be more clear. An internal Lithophane is only for special application where you have some kind of silver gray PLA. Only when that is the case, you have clear internal Lithophane. Otherwise, it's a bit blurry. That is all for the new feature. File create Lithophane. And we are looking at the new method, new shape tile. That is all for this video. Thank you for your attention.